In this problem, we're asked if 5 grams of benzoic acid combust with 22 grams of oxygen, how many grams of each product will form? Next, if the yield of CO2 is only 87%, how much CO2 actually formed? How much of the excess reagent will be left over? And how much more of the limiting reactant would be needed to fully react with excess reagent? There's 4 questions here, so let's take them one at a time. Benzoic acid can be most easily written by condensing down the carbons and hydrogens. This would look like C7H6O2. We know it's a combustion reaction, so we know the benzoic acid is reacting with oxygen to yield carbon dioxide and water. One thing you need to be careful of when balancing this is that there's a couple of oxygens with the benzoic acid that need to be accounted for. Ultimately, what you'll find is that 2 benzoic acids react with 15 oxygens to make 14 carbon dioxides and 6 molecules of water. Using this balanced equation, we're now ready to begin the first problem. When dealing with limiting reactant problems, you want to look at how much of each of the reactants, how much product each of the reactants is capable of forming. We know that we had 5 grams of benzoic acid and 22 grams of oxygen. In both cases, I want to convert those to moles, to a mole-to-mole ratio, and then determine how much carbon dioxide both of those are capable of forming. Benzoic acid has a molar mass of 122.12 grams per mole, and the mole-to-mole ratio is 14 moles of CO2 forming for every 2 moles of benzoic acid consumed. This yields a potential 0.287 moles of CO2. 22 grams of oxygen, on the other hand, each mole of oxygen has a mass of 32 grams per mole, and the ratio here is 14 moles of CO2 formed for every 15 moles of oxygen. Doing this math out, we find that 22 grams of oxygen have the capability of producing 0.642 moles of CO2. However, that amount will not get made because the 0.287 moles of CO2 is less, showing us that the benzoic acid is in fact limiting. This is fewer moles. That is, benzoic acid must be limiting. With this information, we can now take the moles of carbon dioxide that are produced by the benzoic acid and convert it to grams to figure out how many grams of CO2 get produced. .287 moles of CO2. And again, those are the only moles that are produced. These 0.642 moles of CO2 are not produced because we've run out of benzoic acid. So take those moles of CO2, multiply by a molar mass to convert to grams, and we find that 12.63 grams of CO2 are produced. That's part 1 of our question. Part 2 says, if the yield is only 87%, how much CO2 is actually formed? Let's address that question next. This one is pretty straightforward. We'll take our yield of CO2, 12.63 grams of CO2, and multiply it by 87%, which is our percent yield, and find that in actuality, or our actual yield, is 11.0 grams of CO2. That's part 2 of this question. Parts 3 and 4 of the question ask how much of the excess reagent will be left over, and how much more of the limiting reactant would be needed to fully react with that excess reagent. Let's think about a couple of things. Our excess reagent, that's the oxygen. That's what there was more of than what we needed. The benzoic acid ran out. How much more of the limiting reactant? That's benzoic acid. How much more benzoic acid will we need to fully react away all that oxygen? A diagram here might be helpful. Consider this view of the reaction. You start off with some amount of benzoic acid and some amount of oxygen, represented by those squiggly lines, or amounts of benzoic acid and oxygen. We start off with no carbon dioxide and no water. As this reaction proceeds, we lose some amount of benzoic acid, some amount of oxygen, and gain some amount of CO2 and some amount of water. At the conclusion of this reaction, there's no benzoic acid left over. There's some amount of oxygen, and as we've determined, 12.63 grams of carbon dioxide and some amount of water, which we could determine later. Part 3 of the question asks us to figure out how much oxygen is left over. There's a couple of different ways we could do this. We could try to figure out how much benzoic acid reacted. If all the benzoic acid reacted, how much oxygen did it react with? That'd be one good method. Or we could figure out if 12.63 grams of carbon dioxide were formed, how much oxygen did that react with? Both of those are good methods. And I'll pick the first one. Leave the diagram on the screen. So again, I know that I started off with 5 grams of benzoic acid. I'll convert that to moles, and then do a mole-to-mole ratio to oxygen. This will tell me the number of moles of oxygen that reacted with all 5 of those grams of benzoic acid. Convert it to grams, and I find that 9.83 grams of O2 were used, or 9.83 grams of O2 reacted with all 5 grams of that benzoic acid. Remember from the problem that we had 22 grams of oxygen initially? We just determined we used 9.83 grams. So doing a little bit of subtraction reveals that 12.2 grams of oxygen remain. That's the third part of the problem. For the final part, we want to determine how much more benzoic acid is needed to react with the remaining oxygen. Think about this just like a standard stoichiometry problem. If you have 12.2 grams of oxygen, how much benzoic acid is needed to react with it? So we come down here one more time. Try to keep that diagram in. 12.2 grams of oxygen. Convert it to moles. 1 mole for 32 grams. Do a mole-to-mole ratio. 2 moles of acid are required to react with every 15 moles of O2. And convert back to grams. 122.12 grams per 1 mole of acid. And we find that to react away the final 12.2 grams of oxygen, it requires 6.2 more grams of benzoic acid. Let's review the 4 parts of the problem here. Starting from the beginning, we did a little bit of limiting reactant stoichiometry to determine that 12.63 grams of CO2 would be produced. With a percent yield of 87%, we realized that only 11.0 grams of CO2 would be produced. We next determined how much oxygen was used and did some subtraction to figure out how much oxygen would remain. And then lastly, did a little bit more stoichiometry to figure out how much more of the excess reactant or more benzoic acid would be needed to fully react the excess reagent. Thanks for watching.